and the linkage is something like this. Okay, this is just the problem that we will focus. This problem is maybe combination both for the case of nonlinear equation and the finite difference. We will use the same technique like the previous one, like the problem number 3. But for this problem, we will see that this is the linkage, right? We have the linkage, right? That's we have study from engineering mechanics, like the problem of virtual work, that we have some case of this structure. This is this type of structure we may call is a single degree freedom. That is the movement of any point on this structure is depend on just only one parameter. That's for this case is it's just the angle alpha is maybe defined like the degree of freedom of this structure. Okay, so then it means that beta is depend on alpha also. Okay, so for this case, the beta is depend on alpha based on this equation. Based on this equation, okay, based on this equation, we can, if we know everything. We know A, B, C, D. That is the length of the member, and also we have the angle alpha. If we define angle alpha like this, okay, we can determine the angle beta. But you have to note that this formula is based on the angle in radian, right? We have to determine the angle in radian. Okay, so we have to convert the angle to be radian first. Okay, for this case. Okay, do not forget to change the angle to be in radian first. Okay, so we have to determine beta for each table by using the nonlinear equation that we have learned. Okay, so for this case, I will use the second method to solve this equation. Okay, but actually for this problem, for this case, if we focus just only the finite difference, the table is already created for you already for this case. That is the beta for the case of angle is equal to 0 degree is determined by the following table. Okay, we have beta is equal to this. Okay, that is depend on the angle 0, depend on the angle alpha. Okay, from alpha we can determine beta that is compatible with the constraint equation above. Okay, so then I will show you how to determine the angle beta for this case. Okay, that's maybe something like this. Okay, let's case that is maybe your exam. Okay, for the case that if for the exam you may have to determine the beta by yourself. That is hope it's not today, right? Okay, so but this is just the class activity that I will show you how to determine that. Okay, so we may create the constant first. That is we have no A is equal to 100 millimeter, right? And B, okay, C and D. Okay. Okay. B is 120, right? And C is 150 and D is 180. Okay. And we would like to determine alpha also. Okay, so we have alpha. Okay, so now it is in degree, right? Okay, that's maybe the input. That's how I would like to convert it. Okay, to radian first. Okay, so it should be starting with 0 degree, right? And alpha in radian. Alpha in radian is determined by what? We know that 180 degree is equal to pi radian, right? So then we can convert degree to radian by, okay, by multiply with pi. Okay, and divided by 180, right? Okay, so then it should be 5. Okay, so for the Excel, we also have the function that is you may type radians like this, and to convert the angle in degree to be radian, and it should be the same. Okay, that's you right. Okay, for that we may create a table. Until 30, okay, and then we convert this to radian, right? We have the angle like this. Okay, now we will create the constraint equation. The constraint equation, that is the angle beta, right? This is for, we may define beta. Beta is in radian. Okay, if we don't know anything, we can approximate it. Okay, we can approximate it. For the case, we call it nonlinear, right? Okay, so we would like to determine the angle beta, right? Okay, we may use the second method to determine that. Okay, so I will select the second method like this. Okay, this is the table for the second. Sorry. Okay, that's fine. Okay, this should be the angle alpha. So we may starting with 0 first. Okay, we may create a second formula, right? Second formula, message for this case, we don't know xi is maybe, we may define it's maybe that's 1, right? We approximate it to be 1. Okay. Okay, and it should be 1.1. For example, we would like to guess 2 initial gauge, right? This is the open method. 2 initial gauge is not necessary to bracket the root. Okay, and then for fx is what? Fx, we will use the constraint equation, right? Fx is equal to d okay, minus a. Okay, cosine, okay, alpha, okay, and minus b cosine beta. Beta is over here now. Okay. Beta is our case. And it should be square, right? Okay, plus A times sine alpha plus B. Okay. Times sine beta. Beta now over here. Okay. Square, right? I forgot the bracket over here. Okay. And minus C square. Oops. Okay. And then, sorry, what's happening to that? So then, what is this? Oh, it should not have this. Okay. And should not have this. It should be all right. Okay. So you see that it's not close to 0, right? Okay. And for this, we use the F is the approximate one, right? Remember? The F is what? The F is the forward difference. It's maybe equal to what? It's equal to oops. The F is equal to delta Y by delta X, right? Maybe this. Just for a little bit review for nonlinear equation, right? Okay, we have this dl, and also for the x, the Newton-Raphson formula is what? In the case of Newton is second, xi plus 1 equal to xi minus f x divided by f of x, right? Okay, so then now we may define f dx is maybe minus fx divided by f of x. Well, maybe equal to minus fx, okay, divided by f of x. Okay, so it's become like this. So then xi plus 1, it should be what? It should be xi plus x. Okay, it should be like this. Okay, the error is become what? The error is the difference between two values, right? Maybe this one minus the previous one that we approximate, right? Divided by the update one, because it's the update, it should be the correct one. Okay, we have 99% error for this case. Okay, and after that, it should be
อาจารย์ครับ
sorry.
xi บวก1อะครับ สูตรอาจารย์ใช้อ๋อโอเคครับ ผมรู้แล้วครับ
Okay, this is all right. Okay, so it depends on the x, right? If you use the x equal to fx minus, fx divided by f times x, so then xi plus 1 should be xi minus bx. But for this case, I select bx equal to minus fx divided by f times x, right? Okay, just a little bit review for student today. Okay, so then it should be the same, right? Okay, that it should be the same for this case. Now we have the solution of this, right? And it should be 1.659. 6595. Okay, that should be this value, right? Are you ready for this case? This is just for the example, like this. Okay, so when we change the alpha to be like this, so then it's changed. It's become what? It's become 1.5. Okay, it's become like this. Okay, and then when we change the alpha to be like this, okay, so we have the angle change to be this value, right? Are you ready? We do the same thing for the less. Okay, we have, because it's the error is too small right now, 1.2925 should be right this value. Okay, same. Okay, and so on. And the last one should be what? Now we already have the table, right? Okay, are you all right for this case? It's just a little bit review for the nonlinear equation like that. Okay, now we have the table of alpha and beta already, right? Now we move to next. That is for the case that we would like to determine the rate of change. Okay, we know that AB is rotated with a constant angular velocity of 25 radian per second. Okay, and we would like to approximate the velocity, angular velocity of beta of member BC also. That is d beta by dt based on the chain rule. by using chain rule, we know that d beta by dt is equal to d beta by d alpha by dt. But right now we know d alpha by dt equal to 25 radian per second, right? So from the table, we can approximate d beta by the alpha, right? We can approximate d beta by the alpha. So then from the table, we can approximate d beta by the alpha by using the central difference and forward and backward difference also, right? And then this should be h. H is equal to what? H right now, h is equal to this. Is equal to 0.87266 radian, right? Okay, we may use this table, right? This is for the first derivative. We may use table. This should be the same, right? For the previous one, that is should be, we may select this formula. Okay, that's for the middle one. Okay, actually, I think we may do it again in order to reduce your confusion. It should be like this. For the middle data, we use central difference, right? Is d beta by d alpha. Okay, d beta by d alpha. Okay, d beta by d alpha for the middle data, we use central difference, right? It is we may use the order of s squared, and it should be the same as the high grade forward and backward. So it's equal to what? It's equal to the forward value minus previous value, okay, divided by 2h. Don't forget to log the cell if you use the formula like this, okay. So then this is for the middle one. We have this value, right? Okay. And then for the first data, we have to use forward difference. We use the forward difference. That is maybe this formula, right? It should be equal to what? It's equal to fxi plus 2, right? Fxi plus 2. Sorry. Minus fxi plus 2 plus 4 times fxi plus 1. Okay. Minus 3 times fxi. Okay. Divided by h. Okay. Now this. Okay. And also for the final data, we use backward, right? Because we cannot apply central and forward. Okay. In order to type the formula, repeat yourself and recheck yourself for the formula that you use in the calculation. Okay. The order of calculation step is very important. I found that your friend that is have access has already passed the assessment before. Some error that's maybe come from the typing the formula that's maybe missing in order. Okay, so for example like this. Okay, if I use the backward formula, that is maybe 3 times fx, right? Fxi is like this, minus 4 times fxi minus 1, right? Okay, plus fxi minus 2. Okay, and I close the bracket, right? and I divided by 2, right? Okay. And some student time h like this. Okay. So what do you think? This value is correct or not? This value is correct or not? So for this case, checking the formula like this value is correct or not? It's not correct, right? Okay. Be careful that because the order of the calculation, if you do like this, it means that it's not divided by 2h, but it's divided by only 2, and then it's times h. So it is not correct. Okay, be careful to add the bracket to that also. Okay. In computer programming, okay, you have to correct 100%. Okay, you have to keep in your mind that if you correct just only 99%, it means that you're not correct. You is false. Okay, so you see that in computer coding, okay, we need 100% correct. Okay, it means that if we have the error, a little bit error, the result that we have is maybe cannot use. Okay, so now we have the alpha by the beta by the alpha already, right? The final step is we apply the chain rule. That is what we would like to determine d beta by dt. Okay, d beta by dt is what? Is equal to d beta by the alpha times d beta by dt. The alpha by dt, the alpha by dt. That is for this case, it is a constant that is equal to 25 radian per second. Okay, so then it's very easy to determine. It's equal to this term times 25. It's over here. Okay, and that's all for this problem. Are you ready for this problem? For this problem is for the finite difference, just only this. Okay, but for the previous one, I just a little bit review you for the case that we would like to predict the beta from the nonlinear equation. We use the second, right? And actually, this table you can use the Go-seek function in Excel to do it also. For example, if I change it to B1, okay. Okay, if I change it to B1. Okay, and I would like to determine the constraint equation, right? Constraint equation is maybe something like this. It's the constraint equation. I just change alpha, right? Cosine formula. Change cosine alpha, right? Cosine alpha is over here. Okay, and it's cosine beta is over here. Okay, so sorry. Alpha should be like this. Sine alpha. So sine beta, right? Okay. We have this. Okay. And actually, if we do not use the bisection method to determine beta, if we have the Excel sheet, okay, we can use GoSeek instead. That is, use this function, right? Okay, we set up this constraint equation to be 0. Okay, and by changing the data, okay, so then, okay, we have the solution, right? Okay, do it again. Okay, use GoSeek function. Okay, set up this cell to be 0, right? And change this cell. Okay, so then we also have the data that is very close to our result that come from the second method, right? Okay. Okay, we can do the same thing for each data. Set up this cell to be 0 by changing this cell. Okay, we have this function in Excel to solve the nonlinear equation. Okay. Actually, in Excel, you may change it to be the value that you would like to predict. It's maybe not 0 like this. Okay. You're right. That's only 2 data, right? And the final one. Okay, as for this case, we may use GoSeek to create the table of beta also. That is maybe something like this. Okay, and you're right for this problem. Okay, that is the end of our class activity today.